So, not to be picking on Josh, but he has too much traction with some of his comments. And I state his tractions are in error. His traction is in error. All right, so the sheet piling is over here. He's going to describe this as almost post-tensioning with his tightrope idea. This is not post-tensioning. This should be more of a drape failure if you look at it as a drape with this. With this, he also wants to pick on this area over here. Now I'm going to have a lot of supporting data for this, but let's I really did try, guys, to find a failure with sheet piling going in and causing a building to collapse. Closest I can come to, got a lot of tabs here. Closest I can come to was a wood piling system that someone it's an interesting video. We'll get to it another time. Another wall braced system that had nothing, that was not piling system that failed. It was a craziness on the wall bracing. So then I tried to find, I go down, I really try to debunk myself and find other means to get this to happen. Okay, so with that said, I look up earthquakes, because remember, I have a conclusive file that says I must explore other ways for the failure to happen, including my jealous wall. Now, I've had debate with this over someone that was actually there. An engineer was there. They actually stated that it appeared to lack reinforcement at that wall. I never got the images to show that. They were going to send them over, and if you're still watching, I hope you do still send them over. I've kept you anonymous all this time, all these months. I would hope you know that no matter what conversations we have, that it's not going to happen. I'm not going to reveal the source, no matter what. No exception to that. In other words, no subpoena or anything. So the 0 earthquakes in the past year around this specific area, earthquakes near Miami, Florida, United States. All right, this is Earthquake Tracker. Let's get rid of this tab. I don't need it anymore. There are none. See the zeros? Okay. We're going to eliminate tabs as we go. This is frequency. Well, we don't really need to see this one anymore, so let's get rid of that one to make it out of the way. Okay, and bleed water now. So the, where are we now? I'm going to get to this one. I'm going to get to these. And the complaint, it looks, part of the narrative is not just Josh, but you can look down this in multiple outlets or news outlets are slamming this this site. Trying to claim that this caused the indirect failure or direct failure of the structure. Yet we see that this is able to stay in this capacity. We talked about this in the previous video. We see that it stayed in this capacity. I'm going to show you all my research on this, trying my best to find failure by sheet piling. Remember, it's not only has to go through this sheet piling, it's failure from itself, through the soil. It's an existing building with sheet piling on it. So I'm not an 87 Park fanboy, but I could be. Biasly, my bias could be there, but I'm trying my best to find failure. Let me just show you a couple of the articles I hit. All right, so this is effects of piling, induced vibration on nearby structures. And this should be noted on page 22. I'm on page 22 here, page 6. Looking at my notes. All right, it puts multiple pages. It has been indicated in many cases that settlement can occur even at low vibration levels in loose granular soils. You don't need much to create consolidation, all right? To create a consolidation, which I have a tab open called, that I would like you to hear the word displacement. So let's listen to the word displacement and close this tab.
Displacement. Displacement.
This is what we're talking about, whether it's displacement for the frequency, the vibration, displacement of the soils, consolidating granularly, the materials, not just soil, it's rock, all right, So let's get rid of that. As the vibration amplitude is largest close to the ground surface, so you're going to get your highest amplitude at the ground surface. The most vibration is there because you can imagine as the sheet piling goes into the ground, it's confined, and with that confinement comes restriction of its ability to fluctuate, to thing like one of those damn things you flick on, a boing thing, boing boing, you know, a piece of metal. It's gonna, where you hold it by your hand, least amount of vibration, but the outside part that you pluck on, ping, you know, that little noise it makes, boing, whatever noise you want to think of. It's that frequency you're hearing. And it's pressure, it's air making it's in the air. It's just like I'm talking to you now. I'm actually using pressure, vibration from my own voice box, using air, creating a vibration that sounds just like the word, say, no. You hear it in your ears, you interpret it as no. But I'm actually using that through the air, talking to an electronic device that picks up that vibration, interprets it as we hear it, back into a digital sound, and then puts it back on your side through a vibration again. So it's amazing. Frequency is amazing. I talk about this many times about frequency, you know, magnetic frequency and everything. It's amazing stuff. So keep this in mind. As you go deeper, you get confinement with the soil, so it can't do that springy effect, right? The boing effect, springy. So if I were to do it, I would show it something like this, perhaps, to help you see it. So, well, I guess I would make this solid here, and then do this maybe as a frequency. And let's do that. And let's put the soil here, and let's get rid of this. Of course, that's the top grade, and I'm just showing you exaggeration here, how this is the one that's going to be making most of the noise. Down here, it's now confined, getting confined. But at the top layers, it's not as confined as much. It's still pretty loose. But as you go down, say, I don't know, whatever the soil behavior is, maybe 3 feet. And then, so your frequencies are going to be different down here than up here. Up here, it will actually be more frequency. Down here, more confined. Unless you hit a rock, you know, that's a, you know, the effect can have that a little bit of it's a round shape down there. Now this is through all my research. I've been hitting studies from all over the place, and some there's a great study here that they sacrificed their meters. They theoretically dug down so far, placed their meters in there, sacrificial, never to recover them, and they did the digging. I went to look by sheet piling installed by buildings and testing, and I found one that was great by an old theater. I looked up a research that shows that you can be much higher than 0.5 as they scream about. And I use that at California. Caltech allows so much for their building structures that are historical. Caltech, Caltrans, California Department of Transportation. California Transportation Department. All right, so you can see where this would be more like that boing, that thing you hold in your fingers, and you pluck it. And down here, if you hold in your fingers, it's not going to vibrate as much, but out here it will. So this is a lot of that noise you hear when you hear the machine going. You're not hearing down here. You're hearing this thing making all the noise and pressure and sound waves. All right, pressure waves. They are pressure waves. All right, so we don't say this. So as vibration amplitude is largest close to the ground surface, settlement will be larger in the upper soil layers. So the soil will consolidate more. The vibrations will help them consolidate more, where the confining stress is low. So I'm doing a video, already did it, I have to post it for you, and I'm showing a concrete jackhammer. This is going to be a prelude to a video I'm going to show you that I've been involved in many demolitions and worked many heavy equipment, including excavator jackhammers. You know, it's fun stuff to get on, right? But never have been able to put the jackhammer, let's say here, and let's orient this as concrete, this entire white part, and including this is all white. Put a jackhammer right here and start jackhammering, and then luck would have it, wow, it gives me a 10-foot crack here, 10 foot that way, a 10 foot this way, because we need to get 10 feet over. That's where the sheet piling is. You know how many times that's happened? Not once. Not once. No contractor will ever state that they can, that if that was the case, everybody would be jumping and breaking off 10-foot sections. No contractor using a machine that's designed to break up concrete has been able to put the machine back 10 feet, use a jackhammer on an excavator even, and pound through the concrete and get a 10-foot crack. That would be so awesome. They'd be pulling up 10-foot sheets left and right. No, it's a wedge. These hammers are just basically a wedge, and they create spalling initially of the top surface, and then they wedge their way in. You have to be near, say this is the edge of the concrete now. You determine if you come back, say, a foot, it breaks off. You're like, cool. Then you try a foot and a half. Nope, you get a punch through and it doesn't break off. Now you know your limits. Maybe you can do a foot with a larger excavator. And with a small hand-operated jackhammer, we're talking inches, like 3 inches, 4 inches. You go back 6 inches, unless the concrete's weak, you're not going anywhere. You go back 8, and you're just wasting your time unless you get lucky with the shape of it. Like you can go back 8 inches here if you're at the corner. It would want to fracture. Your impact is here. You're wedging off this piece here. And so it's a little bit of method to the madness. It's really technique. But you don't jump into it. I'm going to show the video where I use a jackhammer trying to punch a hole into 6 inches of concrete. I can't get it done with this 90-pound hammer. But nevertheless, I explain that in the video and explain what's going on. And we get no crack even with the frequency so high. I don't get a magical crack happening in that concrete. All right. So we're looking for cracks in concrete through vibration. That's what we're looking for. But via soil first, which is friggin', it's just not happening. I can't find any failures where that's happening. All right, so I've never been able to break concrete by jackhammering into the soil next to it. Oh, wait a minute, that's exactly what we're talking about. Putting sheet piling in a soil, if you will. I'm referencing that material there. And able to break concrete 10 foot away, but wait a minute, got to go through another roll of sheet, or another wall of sheet piling. And then I think about a 12-inch thick, as you saw in the NIST images I showed you, 12-inch thick brick wall, block wall, poured block wall, 12-inch solid concrete reinforced steel rebar wall, not block. To be able to go through that and still have frequency carry through the floor or via the deck. You pick your poison with that. Although the frequency is higher at the top, you'd want to try to go with that poison. But the problem is the testing, the incriminating evidence, if you will, by the company here is showing that the numbers are actually low. In fact, if I go here, I try to find where they would have excavated and then driven the sheet piles down, which would be, doesn't make sense because your sheet pile would be too much. You got an inclined wall. You're trying to put it on the side of a slope. It wouldn't work. To help you understand it. So you drive the sheet piling in first. Well, they did that. Look at it. You can see all the surface around here is all covered around with not been excavated away. Maybe it's been graded even, flush or whatever word you'd like to say. But and we got existing structure here. So this is very interesting. So this building failed here, and blamed on this one. This is an existing structure. I don't know if it's still existing today or is that the pool. Did they remove it? I don't know. If it's there, you can go inspect that building because that had sheet piling right in front of it to look at it. It's had glass. Let's see if the glass was able to get fractured or doors got stuck or any history of that in the reports against this 87 Park. Do they have any documentation of that? So I would guess the lawsuit people, being neutral in this now myself, they should subpoena their documents, the contractor's documents and reporting of the daily reports of what they took note of. And maybe they did take note of a cracked window over here, and you could say, oh, use that against them. You cracked the window within 10 feet. This window would take, it's an old window. I wouldn't use window. Whatever. Just look at, see if you can find it. This looks like the equipment set up over here or something like that. See, it looks maybe it's set up over there, the piling equipment. Yeah, it got blown out now, and so I'm not sure. So the piling, interior sheet piling. So yes, so it was done, and it was. Remember, I said above ground is where you're going to get your most frequency. So it had soil around each side of it. We saw that in the image they present, where we see the soil pretty high up. Now, Josh, I'm triggered by Josh a lot because frankly, he's, what I think of that. I saw that crack at the top of the structure there, and I'm like, you know what? In another video I did and I didn't post, I said, that's nothing. That's just the, when I saw the crack up there, I said, it's nothing, just a cap. As you can see in this image, that cap is continuous, and it's a cap, and it's just a, it's just continuous size, shape as a cap all the way down, and it's got a fracture thereupon all the way down. Now this is a little bit of an overlay with their plaster work, or a fracture. Can't tell, it's pixelating on me, but you zoom out. So you can see that crack that he makes a big woo-doo about is nothing. It's already presented. It's already there. Now this equipment, I would argue, and this is where my bias is in NV5, the engineering company there, might have been using some equipment at a scope. How about that? Because, you've got this wall here, and they pull back this, and did they not see the sheet piling there? I mean, I wish I could see it. Is this the sheet piling right about there? I just, is that the shape of the sheet piling? Am I being biased to say that? We see the wall also is offset of their, remember this was replaced and made higher, to be tall. I don't know, it went from 4 feet to 5 feet and some change by their permitting, when they asked for permits. And you can see this looks like, they didn't mortar it. Could be simple weep holes that they allowed for water to come down the wall and escape out from their own wall system and from their pool system. Remember, they're claiming that the water buildup that Josh is claiming, and also they're claiming, is the water built up from the structure poured down to their structure. Huh. Isn't that amazing? Well, you know how I like to curse every now and then. Get the fuck out of here. You got a deck up top that's got a water problem. It's a roof for essential purposes. You say you got leaking. I show the pitch in one of the video of it being low over here. In fact, right where we have the collapse, I show it in one of the images that it is low over there. We'll come back to you. So I show that over here when we remove this, that it's low over there. There's the hole opening there. This video is probably going to be close to 40-50 minutes long, but let's see over here. I show it in one of my videos where this has a little dip in it, and I said, oh, look at that dip over there. Isn't that right about where this whole fracture is? Oh, wait a minute, look at all this standing water here. And yet they want to claim the building next door is pouring their water off onto it. Well, what happened before that was it was a friggin' 40-foot wide street, I believe. We got vibration coming off the cars all going up and down there, right? All right, the parking, it was there all the time. How come they don't blame some of that vibration and forces? All that rain and all, how come it all of a sudden is not an issue? And they said it built up water on that side, is what they're trying to claim. And I think that's Josh's claim to fame also, that the water built up. So I just find that, you're not staying congruent with the data, and you're not letting data, you're just throwing, you're like, hold on, let me do it. What did I just do? I had a straw and I put some cotton, some things in it, a spitball. Oh, that's right, a spitball. You guys know what that is. You're just spitballing now. It's just, random, trying to nail it, getting close. Although you're probably pretty good with the spitball when you were kids, right? You probably nail it pretty good. So no spitball killing. No spitballs from kids, only adults. I don't know, some of you guys play that game still. That was a nasty game to play, wasn't it? Roll up part of the straw. I'm just giving you a little flashback. The image I'm trying to show you is that one by that was deep over there. That was showing the dip. Well, maybe I'll make it the thumbnail again, but we see reinforcements over here, and it's been stretched, if you will. And that's our little bow, our jealous wall. There's where the firemen are, so we know where they are. And that was that planter box area. But this is bulging outward as it rotated, I believe, as the deck went down and rotated, that it caused that outward thrust. I like that, the thrust. All right, so let's listen to Josh on this part, and then we'll take him to one more part, and I won't beat him up anymore. We'll go back to the vibration. But Josh wants to represent this side of it. I'll take it on. Remember, I can't get them to come challenge me on a live chat here, so I challenge them this way. You know, you guys can go, you know, I'm sure he's looking at the content, so hopefully he'll bail on it. All right, so it's not post-tensioning. I'm trying to, you know, I'm not trying to troll him and say that, but he used the tightrope thing. I'm like, that's post-tensioning now. Wisely so, you got me thinking that way and not this way. Now, he's also going to say they didn't have the night cycles of he said about going in and out at nighttime. He's right about temperature variances, right? So that's good, except for counter to that, we have the report where that's actually addressed. And in the report, it states that that's been addressed and that there's no temperature variances issue. Oh, right, I got multiple tabs open above this one. So let's hear this first.
Buildings are under the greatest stress of thermal expansion and contraction forces
Okay, right there. Greatest thermal expansion forces, contraction forces. I'm looking at these tabs. I'm trying to grab the one that has multiple tabs on it, and that would be this one and the one over there. Oh, it looks like I get to show you this one. So I try to find building collapses while sheet piling, and this one is not sheet piling. These are post. This one is interesting too. We'll get to that one because I think that not in this video, but it'll be fun to watch on its own. Interesting to watch on its own. So in the report, it's up above me. So in the report, I gotta go a few tabs. This is jumping a little bit, but the actual insurance person, in part of their lawsuit, they're going after the insurance company, represented by Peter R. Costello or L. Costello, whatever this person is here, and they make it clear that this is the representative is a deceased person at all times material. The deceased were members of the association owners of condominium unit 903. It appears they're stating that, and I might be getting it wrong, I looked it up and it keeps coming back that somehow it's tied into this person is deceased, that it is that he represented the insurance company, specifically Peter Costello owed a duty to deceased as members of the association to advise, right? So Peter, I'm not sure if my comprehension is right on that. I'm looking it up. Tannenbaum Insurance, through its agent, employed Peter Costello, whatever his name, to advise the association as to its insurance needs and obtain adequate and proper liability. And right here, Tannenbaum was a domestic limited liability company duly organized and existing pursuant to the laws of the state of Florida, and was engaged and is engaged in the business of selling insurance. Upon information and belief at all relevant times, Peter C. Catello was and still is a licensed insurance. Well, if he still is, he can't be dead, right? But it's weird. They say that they make it seem like he's deceased. But I looked up, I Googled it. It looks like it's I can't quite get his death there, but a couple times it relates back to his death. I think that's because of this document. I'm not trolling you guys. They're really, just really weird the way they word it. Upon information and belief, Tannenbaum Insurance, through Peter Catello, they dropped his middle initial, agreed to obtain adequate and proper liability and property damage insurance coverage for the Champlain Towers South and represented it to Champlain Towers South Condominium Association Incorporated that it understood their needs and requirements for insurance. It understood. Referencing him is it, and the company is it. Specific, Peter Catello owed a duty to deceased, and as members of the association, it's going to give the apartment number, right, to a condo number, to advise and proceed, right? Okay. So 902. Where is 902? At all times material, the deceased were members of the association and owners of condominium unit 903. That's confusing to me. I'm just going to now pull this tab down and shrink and blow it down to away from us, because it doesn't offer any more in this conversation right now. But I wanted to bring that to you. All right, so this is the oh yeah, we already did over that. I just double loaded it. Oh yeah, I just kept finding it. Every time I looked at it, it kept bringing me back there on deceased. So that's like multiple cycles of it. All right, there's a drawing. This is where we talked about already. I need to move over a couple, 3 tabs. Couple, 4. Okay. So this is the report from the 9-page report, the preliminary from the engineer that worked for, it's for, I don't want to move the tab yet, move it up, for Champlain Towers South. It is also important to note that the replacement of existing deck waterproofing will be extremely expensive, as the removal of the concrete topping slab to gain access to the waterproofing membrane will take time, be disruptive, and create a major disturbance to the occupants of this condominium building. Please note that the installation of deck waterproofing on the flat surface is a systemic issue for this building structure. Okay, so he's talking about there's an issue with waterproofing. It's a problem with the waterproofing, not that the water's flowing from the other buildings into this. He's talking about its own deck. Well, let me get to it more. He's talking about all the rebar failing in multiple places, but I think I have it more keyed a couple tabs over. Right here, under noting cracking, spalling, peeling, signs of moisture penetration and stains. Concrete columns, exterior walls, balconies, garage plaza have experienced concrete deterioration, with the majority of areas being adjacent to and under the pool and planters. Adjacent to and under the pools and planters, the majority of the failure. There's also some isolated slab cracks in the soffit of these slabs. This soffit word is very interesting. Is he referring to the slab, the area by the planters, where it turns and goes up, and that's fracturing, cracking? That's critical, because that's that drop slab detail, slab drop detail. So that's that part where it goes like this. Bear with me, I did a video on this, and I keep looking for the it goes this way, and there's your deck. So here's your deck, here's your upper deck that goes into the building. Here's 111 right here. Oops. Behind here, this is 111, let's call it. And he says soffit detail. There's the tile and everything else and planter boxes. But is he referring to this as a soffit detail? And that's the only thing I can think of. Don't say. Only thing I can think of there. 8% of the soffit's garage plaza slabs. 8% of the soffit of these slabs have experienced concrete deterioration. Down here again, soffit. Okay. Up here is contraction. Good. Existing slabs appear to be adequate to accommodate building and plaza thermal and moisture volume effects. So he's covered it, and here this engineer is the one that inspected the building. He stated that this appears to be adequate. So, Josh, it looks like you got to go back and amend your statement with your throwing it at the wall there. If anything, you'd like to know where it is. Now, so that's that one, right?
At the coolest time of the night.
So that's already addressed, and that's his whole big thing. And then he refers to the tightrope, right? Where he does his tightrope thing. And where's this tightrope guy? Right there, tightrope. Well, it's not a post-tension structure. So there's no tension like that. The tension can be created through the deflection of the deck and then putting tension in the steel. And that would be after deflection, not before. Before it's just nothing. All right, so then he hits on another thing I want to hit on with this thing here. What he's
so this can explain one of the things that has sort of, I think, bothered a lot of people is, well, if the slab was so under-reinforced over these columns, why didn't it collapse over the last 40 years? And I think a good argument, and I think Professor Lehman...
now, you know, he triggered me on that one, so I'm biased on that. She, her, the one that's... And I'm biased because she made it clear on Twitter, communicating with me and this other engineer over there, that before she deleted her account because I outed her for saying, wait a minute, how are you now bragging about trying to get interviewed? You guys can find my video on that. Bragging about trying to get interviewed on this when she makes it clear in her comments when the collapse first happened that you cannot evaluate a structure by its failure state. So she's stating that NIST, all police departments coming out looking at collapse accidents and etc. It's useless. You can't do it. NIST, OSHA, everybody trying to do an investigation after is just useless. And then she steps up as number one and doing it. Obviously, Josh is trying to triangulate, side with her to make himself look, like he's doing great, calling her not gaslighting, but it's an effect, a halo effect. So if I triangulate with you guys, I could do it multiple times. I can grab over here in those articles, instead of just reading to you, I can say, PhD this said that. And you're like, oh, wait a minute. PhD said that, so I'd have to, Kai must be nailing something here. No, I'm giving you the data. I'm not giving you qualifications or anything else behind it. I'm giving you showing you the results, the test results. I don't care if it was done by a grad student or a non-licensed person. I don't care, as long as the testing was done and the data is all I care about. I don't care about the person that finally put the report together. That doesn't matter. We know that in the field they were done by many people that didn't put that report together. It's the layman.
Is also kind of making a similar argument, is that it was this connection sort of saving the day and doing more work than it was really expected to do or ever designed to do for many years, which prevented it from...
And that's his tight work wire thing. He's trying to say it's holding here and then over to there. This has the wall with the greatest critical shear area. Remember, the entire wall is connected. So what would be doing the most work is not the friggin' wall, Josh, but each column in the critical shear area would be doing the most work. I don't understand your logic besides you and Lehman picked the wrong field to get into. So you picked the wrong field. You got just enough to make yourself look stupid. I'm sorry for going that way, but I just triggered myself on it. This whole wall is ledgered and connected. And he's saying it's doing all the work. Well, what's doing more work than these friggin' wall or each one of these columns and the span between them are doing more work? What's doing more work is down here with the car loading. Oh, friggin' triggered. I wish I could have done this much more calm with you guys. Now, you know the amygdala, how it's a jerk.
From collapsing until the fatal night where it...
I can't take it. All right, there's the crack he's going to mention. Oh, maybe he'll get it over with.
Did. And so here's some pictures. So I'm going to go back. I'm going to look at these pictures to give you some perspective.
Let me
We're
fast
going to be looking at this wall, okay? And we're going to be looking at it from this, zooming in here a little bit. You can see a little bit of what's going on. Here, I want you to pay attention and realize that you don't see any zipper.
He
right
doesn't
here.
he doesn't like zippering. All right, probably doesn't like it because I said it. But he's going to talk about the little crack. I didn't miss that crack up there, but I knew about it from the other side of the jealous wall. It was insignificant. This is where it offsets a bit, where we see the block wall on the other side. We see this wall is in plane, not cracked or fractured. We don't see it all torn apart. With that said, this has some separation right here, so it did take a bump, a rotation. You can see it right there where it fractured. But that would be that area there, and here's more of a clean
You
break.
can see those same identifying marks. Now, that's not the only thing I'm relying on. I've gone back and forth and checked these photos to make sure that we were in the same correct corresponding area. Now, there's something really interesting I want you to observe in this photo, and that is that the concrete here, the slab that would have been coming out from here, all right?
Hold on, guys. I got to...
Where it connects to the building...
I can't do it. I can't do it. I can't do it. I can only take so much of... you guys can imagine I can only take so much of my patience. All right, so this is not a tightrope, all right? It's not a tightrope. Once you get to flexion happens, the steel becomes active. All right, it becomes... but it's not all the steel. It's the bottom steel becomes active. The top steel becomes active. But it becomes in a compressive and a pushing away format active. Everybody just thinks it's compression. Well, it's also resisting because it's not for free. It just doesn't. It's just not bowing in. It's not bowing down. It's also still trying to maintain, and all the forces it's stopping. Also, they're working together. And I can show you that in one of my models when I do one of your models for you guys and show you top steel, and then load it. Without the bottom steel, we're going to get just a fracture and open it up. But we won't fall if I can trap it, confine it at 2 points. I can load it all I want, and that's one of the things now. Bailing off of this video, we would talk about the epoxy that goes underneath of it, that the engineer here calls out as ineffective. Well, that's explaining that it's opening at the bottom, which means it's deflecting. All right, expansion good. Again, he says contraction good. Existing slabs appear to be adequate to accommodate building plaza and thermal moisture volume effects. And this is Josh's thing about water, and also the tightrope thing is just off. You know, he's just not understanding the behavior of the concrete there. All right, and also the connections. That this is not, or like Earthquake Lady says, Lehman says, and he supports, this is not the weakest part. The weakest link is out here, guys, where you're now made it into columns. Not the friggin' ledger. Not where it's all connected. That is just ridiculous to state that. Ridiculous. The weakest part is out here. So I'm really triggered by this. Let's go back to what I wanted to teach on this one. And that would be calming down, frequency, and we're back to the collapse again. And I'm trying to find where the vibration could have caused this. It could have caused the frequency there. Not for Josh, not just for myself, but also for the first person that said it to me about that. I'm trying to make it fail there, but the material and its location does not state that. But I'm just trying to see if we can get some damage there at least. I can't get through the sheet piling. I can't get through the sheet piling nor the 12-inch wall that NIST shows. And this article biasly leaves out the sheet piling here, where they just show a wall, but they're leaving out, and they show the sheet piling here, and then here they, oh wow, let me zoom out. This says 10 feet. All right, right there. And that's the walkway, and your sheet piling, I believe, is back here, so it's greater. And then over here, they just leave it out. They just do measurement. But there's sheet piling there, along with the wall system. All right, so this one already beat up on, already stated that, look, they're driving this in, it's sliding in like butter. In fact, I used their documentation to show the speed that it's filing in, like going in like butter. You can see at their southeast corner of the perimeter wall of 877 Champlain, using Champlain Towers South. Southeast corner, you're coming in, that starting point. Oh, the starting, is that the starting one? Yeah, this will be, where's our footage? Yeah, that's the starting corner. So they don't count the starting one anyway, but already they metered it. And they have it at exceeded. That's vertical though. We care about transverse. Remember, the highest frequency is going to be at the top there. Okay, they're bragging about it exceeded it. Southeast corner. All right, let's go find the south. Wait a minute. Southeast corner is over here. Then we got to come over at least 10 feet. So it exceeded here. What's there? A swimming pool. Swimming pool didn't fail. All right, so it exceeded over there. We got no failed swimming pool. Okay, so I'm going to discount that part already. Ooh, I need to stay in that tab apparently. So, wait a minute. No, it's over here. Hold on, I lost my location. I'm going to pull this down. Okay, yeah, let's do that. Let's move this over. Bear with me while I shrink this. It should resize, and it did not. Great. I'll move that over. Okay, so then we come in exceeded. Oh, wow. Better look into that. Well, this is 15 feet over, and the timeline matters. So at 2:53 p.m. on this date. Now, so on this 4 days later, I don't know, you can find it maybe a weekend. It exceeded on the longitudinal frequency. Longitudinal, huh? Vertical. And transverse. Well, I really don't know how he had it configured, how many of these devices he had set up. Because obviously you can go around a clock with this frequency. And it depends where it was, his point, where he put this. How did he measure? Is he, I hate to say it, is he a surveyor? Did he measure using a tape measure off of this wall to put his indicators? What's over here at the time when he exceeded? Are there other things? Were the crane banging? Was this a frequency, the peak? Was this a continuous height up here? Or was it just one bang up and down? Bing. One hit, one up, one down. So what I did was I looked for what causes buildings to collapse. And so I look at the Richter scale. You know, this is what we're trying to find. It turns out you need a 6.5 to start getting buildings to collapse. So you need some serious, and we couldn't find an earthquake. We couldn't find an earthquake there, so that's out. So the earthquake thing, and I looked for the Richter, anything. So it would have been somebody doing an explosion. In fact, the building collapse didn't even cause it to register on the Richter scale. At least it's not on the one I found. If you guys find one, that would be great. So we have a peak here, and it doesn't say how long this peak was, but I tell you what, how long it wasn't. This is 9:04 a.m. on 3/3. And then, hey George, that's George here in the background. If you just heard that little purr. So let me move the mic over. I think we were picking up. Yeah, we were probably picking up the fan noise from the computer. Let me move the computer away from you a little bit. All right, that should really help you out. Sorry about that. Hey, Georgie needs attention, so I gotta switch fingers to the keyboard. So if you look at the overlapping times and also distance, so this is 15 feet away. We're still within the pool. 30 feet away, we're still in the pool. 45 feet away, well, 30 feet, let's just say 30 feet, we're still in the pool. So let's pull up the pool. So we're still in the pool zone, right? We're still, hi George, what's up, dude? I think I can get footage up top. Okay, so I'm gonna have to go to another one for footage. Let me scroll up. George, I'm worried about him stepping on the keyboard. He'll trash the video, in which case we're gonna do a part 2. He'll make a move on me out of nowhere before I know it. I'm crying to you guys about it. All right, we can use this. All right, let's look. This actually works out good. So let's go 30 feet over. So 30 foot puts us here. Zooming out. So here's our KLM. So here's where we need to get M, K, and L is what we're concerned about. And if I let's use the top. Let's use the top since we can line M up and we got it in our brain. So here's the path. So there's 11 feet. But we're not at the corner, are we? This is the corner of the structure, so this doesn't work out for me. Let's move. So I got to do some extrapolation. Hold on. Let me line this up. So that, let's just call that 20, and that's 20. That's 40. Let's call it 51 feet from here to here, from M to the first column. 51 feet. Now let's go back here and overlay the pool structure with the make sure I'm in the right building. So 51 feet right here. Oh, I'm sorry. Let me show you how I got there. So there's the M. And I know 51 feet is from here backwards. From here backwards over to the PMNOP. P. There's P. And I slide P down. And there's the columns. That's the P. Let's see how using the mouse, just scrolling up. P is here. So P is right there, and I have to go 51 feet over from here. All right. So here, just keep in mind, this is P, right about there. Right here is the corner of the structure, the southeast corner, where they work their way over. And so I need to get footage from here to here, because that's where they're measuring from. So I have to go to that longer one. Hold on, let's find it for you. And then you'll see that when we start lining up. La 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 la. So bear with me on this. It's worth your energy. And I mean, I'm going to get to the testing, all those tests. But you can, I'm going to let you find it if you want to research it. But otherwise, you'll have to trust my research. And I keep finding more and more reports and studies, and man, I can't find them showing a collapsed building. I'm doing my best. I'm using historical buildings too, which are you know, you would think would be weaker. They do have stone foundations though. That would, a lot of them do, I think, would, because they don't talk about it, would help bridge the vibration. Because they'd have to go from one stone, hit an air gap, if you will, and then another one. I really need solid. I need this same setup. You know, 10 foot away, another piling system. And basically I can get that by looking at this structure and its piling system. They put piles pretty close to each other. But there was sand there. And so that doesn't really help me. It would help me to determine if they, how plumb they installed the two of them. Because it would tell me how much pressure one was creating on the other. All right, so so here's our wall system. There's the pool. Remember, they come in so far into the pool, but I still need distance. There is a distance one. Hold on. The mouse is moving as fast as the screen will load. 51 feet to P to M. Okay. Oh, my survey. I don't know if I have footage on the real survey. But the real survey also does not show a deck deflection. They had a real survey of it, and they changed it from 11 foot 10 to height of the deck. To help with global warming, I guess they call it now 9 foot 3, 9.35, I think, is what it comes down to instead of 11.10. I did deduct for the apples to apples. I kept it that way. No overlay counted at that point. The existing structure was 11.10, top of the deck. So I made this existing survey now it's calling it 935. Interesting, was it always 935 and never made the 1110? Question mark. I doubt it though, because the street, I did a video on that. The street shows it that the back of the pool deck, top of it at 1110 is about equal with the street on the north side of the structure. So it's just like you could walk off the street, walk around to the back of the building, and be right on top of the deck. And you'd be elevated off their, whatever their benchmark is, wherever it is located. If you guys could show me that benchmark, I'd kiss your heart, because I can't find the benchmark of their elevations, neither on the new survey or the old one, or the old one where they claim 1110. And none of these drawings could I find a benchmark. I really wanted to be a hero and find that. I lacked the shield and the cape. I couldn't find it. Oh, shout out to Rosemary. You being quiet. Maybe you're getting blocked your comments. Giving you another shout out. Thank you for your donation again. Rosemary's like a continuous donator from you guys. Gotta give her shout outs. So look, planters. That's why Rosemary gets custom videos too. Of course you guys do also, but Rosemary gets special attention, even though I attack her sometimes. So there's this is where the other side, this is the south elevation, right? And so this should be 11'10" here. And they don't show the ramp in there. I wonder when that ramp came. I'll keep dropping little dimes like that so you guys can possibly find it. This is very interesting, isn't it? Open. And then this is, this says plus 2'10" right here, basement floor. That's over there by the garage base. The garage base. So this really makes me wonder about this plan. I'm not going to dive into that at this time because the heights still come out to where they come out to. That's a little question mark in my mind. Someone wants to beat me to it. Josh guy, if he wants to beat me to that elevation thing, he can have at that. And if he does, and he can, his amygdala let him take it, I get my hands out. Because he can possibly find it. All right, here's the roof, so let's blow that off. I need that depth. Damn it. We're down to 6 pages. We're getting close. Oh, I could have went over here and gone faster. There we go. Yeah, this is the one with the outside measurements. About time, damn it. So, wouldn't that be something? Isn't that something? It's 36 feet. 36 feet, then 200. But so we go, it's right about 36. Would you agree? That's where I was a second ago, over on right there. Follow that line up. So follow this up. And it's staggered off this line a little bit, which is right about in line with that one, which is P, I believe. This is P. And I need to get over to M, which I said was 54 feet. So I need to go 54 plus 6, 60, plus 3, 90 feet. 90 feet. So what I did was I went from here. 90 feet gets me to M, and that zone would be from here on down to here. They're what they call their depth zone, right? Basically. So let's do that. But remember, at 90 feet, right about here, I got another pool in the way. I have a hot tub in the way of that frequency coming across, if you're going to say it's coming across the deck. All right. Now you could say coming across the bottom, loosen the soil up magically, all these feet. And make up your mind, though. You can't, you can have your cake and eat it too. You can pick multiple failure paths, but support it. You can pick it up here, but now you got to be supported with the real evidence, the real data that's there, the way the collapse happened, the way it's leaning against the wall and not falling away from the wall. You have to show the fractures. You can have it coming and loosening subsidence-wise, loosening the base of some of these piers, and dipping down and pulling on the deck. That works for me. Works for me not here though, because I looked at the images and we don't see this fractured up that way. So you wouldn't be able to do it here, but sure, if you can get one of these to dip, and that's why I found it amazing they did not take, we didn't see them do surveying of the floor. I didn't see any fractures in the floor though, because you would think if it dipped, you would see fractures. Didn't see that. They used the sounding equipment we saw with NIST down there, but they didn't open the floor up and look for the hollow void to prove subsidence, which would have been great. I think their sounding, though, came back with, it's solid. You knock on something, no echo, then it's solid. You knock on it, it's an echo, you're like, oh, hollow here. You can use it with a hammer in your sidewalk. You can literally tap it and hear where it's voided underneath. That's all that device does. It's the same thing, same principle. So I think they found that it was pretty solid under there, or I think they would have cut open floors and wanted to see how deep it actually was hollow. But I saw nowhere where they cut open the floor. We do see they seem to have probed into the one column here with pressure testing, with what appears to be pressure testing with the NIST equipment, the soil, how much the resistance it could take. With that in mind, we got a couple of things that, the subsidence thing is crazy, where that FIU University professor comes forward right on the day of the collapse, the morning of or something, and wants to talk about the structure, but yet his FIU bridge collapsed and he says nothing. He doesn't show his face then saying, oh, we need to get to the bottom of this. It's probably subsidence or something like that. No, they've never mentioned one thing, their entire university, and I had great respect for that university up until then. They got contracts from the government, everything else that university does. FIU, huge government contracts, everything from space to the structural stuff. Yet now we find that they're church mice on their quiet means quiet as church mice. On their own FIU bridge collapse, they got nothing to say. They're not setting up any models or anything else. But this one, they want to say subsidence. It works in their favor to talk about the flood money. And they get tons of flood money if you can claim that it's tidal warming and all this other stuff. Tidal warming. I kind of like that. Tidal warming. All right, so this says elevation plus 10.85 feet. Pool deck. And it was supposed, 1110 is where, so you can see it changes a few times, and I talked about that just a moment ago. This wall is 40 inches, now it's higher per permit. Anyway, these were here, these planter boxes were here way back then. I know that tool guy said that they were added later or something like that. I don't know what the hell he's talking about. These plans are from... and I saw it in his comment only, not that I saw his video. And these are the original plans without the hot tub in it. And they show the planter boxes. See the planter boxes? They show them. They don't show the little front ones the ones that were added later, the bump out ones. Maybe he's talking about those, the ones that are over the columns. But that does get added in these plans. So, in the hot tub. The elevation I'm talking about is, so right here it's saying, I'm blowing that off. Let's get back to this. So 54, 60, 90 feet. We get to 90 feet to get to M. We get to M. Let me do this real quick. Hey Kyle, let me call you right back, baby. All right. Okay, I'm gonna help you out. Give me a few minutes to help you out on that. All right, take me. All right, so look, 90 feet. Gotta use one. Oh, my disk is almost full. Shoot, I used too much memory. Oh gosh, I gotta do this or it will crash the video even. 90 feet. So let's get to this. Oh gosh, I don't know if I'll make it in time. 45 feet, doesn't count. All right. We need to get 90 feet, 60, 90 feet. We're exceeded right here. This is the speed version of it now. We'll do a part 2 maybe. 90 feet. We're right around M now. We're very low in the 2 directions, but 1 direction we're at 0.65. This should be acceptable in California. Vertical, and that's vertical. Vertical. What did I say? Vertical? Oh yeah, vertical. All right, that's that way. And the other direction axes, the 2 axes they choose, very, very, very low. 90 feet again, exceeded. Vertical, very low. That's on 3.9. Look at the timeline. Look at the timeline. 11:47, 12:40. Looks like they took a lunch break. Oh shoot, gotta hurry this up. All right, 90 feet again. Percent of limit, 50%. They're now in range. 90 feet. 90 feet in range. They're staying spec. 90 feet. Now they bump over to 105 feet. That's 15 feet over. 15 feet. It says exceeded. That's on the vertical side. One more axis here, but now we're at 105. So we're 15 feet off of, sorry for the hurrying it up. We're at 90 here. Now we're 15 feet over. So that's right about, you pick it on the wall where you want. Shoot. 135. And then after that, we're up here. We're pushing beyond. We're pushing back into the main structure to the left. So all these would be insignificant. Look at the numbers again. They're very low. Only in the this axis is higher, but this is not. This is also you have to worry about. Was it one peak only? Just one bump, one loud hit like that. It wasn't continuous. I'll prove this to you in the concrete stuff. Looks like I will not be getting to the rest of this data for you, but I'll try to give you a quick thing of it right here. You can grab this link if you want to. This is the Michigan study on amplitude and pile driving. And I did not mean sex. Effects of pile driving, amplitude, that's that one. I'm going to push it here so it maybe will stand out. Oop, that didn't work. I'll probably grab it again. Yeah, I lucked out. This one is the mechanics industry, structural impact response for assessing railroad vibration on buildings. So this is the one I found a high frequency, continuous for many years. You don't see New York or Boston or Chicago buildings collapsing with that continuous frequency hitting them all the time. San Francisco, etc. They're still up there with all that continuous frequency. This is the tooling they used. You know, if 87 Park could probably countersue this company and try to find out if they used the right tooling. They should have done it, set it up better, and say you didn't represent us good enough. I would say that would be a way a lawyer would probably go at it. You know, attorney-wise, try to find, you know, bounce on them that you should have, the equipment is wrong, perhaps, and location of it, and choices, and depth. There's another one I want to show you if this thing will hold out, and I'll lose all of it otherwise. This is the railroad one. This is the railroad vibration, right? Okay, so over here, I know what I got to do. I got to move things over to be able to do this. Frequency, that's the device. Just got to keep moving them over. Great. This is something you should look at. Intensive. Let's listen to it.
Are based on wave amplitude and degree of ground motion.
Is degree of ground motion. Listen. This is how you.
The Richter scale is open-ended. It is also logarithmic, which means an increase of one magnitude corresponds to a tenfold increase in wave amplitude.
So this is how you help you understand it. If you want to go back to old school Richter scale stuff, that's basically what you're trying to evaluate frequency. There's your different axes, as I was trying to show you, that it's multiple directions that could be going. Did it go that axis? Was it towards the building or was it away from the building? Which axis is it? Because it's clearly they could have used more testing devices. They could also put two of them in the way, meaning one's here. Here's your sheet piling going in here, right? Oh, darn it. So this is one of the through all my research, what I've discovered about the best way to do this, testing-wise, is say, hey, this is the sheet piling, all right? Let's leave that. You put testing equipment here, testing equipment here. High and low, deep, shallow, sacrificial. That's the best test I've come across so far. And you can now profile what it's doing as it's being driven down. The sheet pile is going down the ground. It will say, okay, you're here. And what it just comes down to basically is you're going to get your higher number at the top. And unless you hit a stone, unless you get ricochet off an interior wall, etc. This is your amplitude, the frequency, the how its machine's driving. Trying to find the one for you. Structure analysis, reinforced concrete building with the exit. This is exciting of micro tremors and passing subway trains. This is the other study. It's very interesting. This is Beijing, China, and Beijing does crap work on construction. So if it's going to collapse, then it's going to be in Beijing because they've got shit construction. That's why I picked that. They call it tofu construction. I wanted to get you the one from this great one that I'm hitting on. That's really railway. It's a historical building one. Oh, it's probably in multiple tab one then. All right, so no. Multiple tab one, not that one. Perhaps this one. I don't think so. So this is another frequency one. This is you've got to find this one. This is page 58. Yeah, this is the one that's even talking about how this one's pretty in depth, talking about how how to straighten it back up, how you would how when you're compressing your sheet piling, when you're stretching it. So this is evaluated after the fact. You can go there and look to find that sheet piling, go down there and investigate how it was done. This is your forensic ability to see how it was done. You can figure out whether they straightened it back up by cuts, etc. This is what I want to share with engineers that might want to go down that deep. So this is how you are installing and how you're evaluating. That's low clearance headroom stuff. Let me see this one to the left. I wanted to show you the. Let me scan up. I made it. There's a 58 pages. when you're lifting it, banging it around, that gives you a peak. That will give you a peak. And this is what it would look like. See the locking, the interlocking, driving down. It just slides in. This stuff really is nice. Oh, that's water. This one is called Master Thesis. All right. Time Historians, 64. This is the historical one that I was talking to you about, where they're pile driving. Right here, sheet pile line. Look at it. It's right up to the building. This building does not fail. This is an historical building. You can look up the theater and look at it. It doesn't fail. The sheet piling went up to it. This is a great one to look at. This is not going 10 foot away plus another 50 feet and all this other stuff. It's right there. They have the testing that's sacrificial in this study, where they leave it there, one and done, gone. They use a longer probe system than the other one. Oh, that's the end of the stock day. All right, look, guys, love you. I got to go. Got to make that phone call back to them. And besides, I think the memory is going to cut me out. We can talk more about this if you so choose. Love you. Thanks again, all my donators sending me little gifts. And also, because they're break, I'm not calling them little. They're little packages, my little thumbnail, my cards. They're so damn great for you guys sending me that. And again, shout out to Rosemary. She's like my crazy donator. That's awesome. And I don't mean you're crazy, Rosemary. I know I am. Bye.